In this lesson, we're going to look at how we go between the name and formula of covalent compounds, or also known as molecular compounds. A few things we should know about molecular compounds. They're also called covalent compounds. These mean the same thing. They contain discrete molecular units, so individual molecules that match the formula that we see. They're usually composed of non-metallic elements. We can occasionally see metalloids in there, but we're not going to worry too much about that at this point. And most of them are binary compounds, meaning they contain just two elements. Although, of course, there are exceptions to that. So those discrete molecules are separate, distinct molecules from one another. Which pair of elements will form a molecular compound? We have iron and chlorine, carbon and oxygen, sodium and magnesium. We see that carbon and oxygen are both nonmetals, so they will form a molecular compound. We're going to look at how we go between the name and formula for molecular compounds. And the naming system is much easier for molecular compounds because it tells us exactly how many atoms we have in each compound. And the reason for that is that there are multiple compounds that can form from the same combination of elements. And we'll see when we look at ionic compounds that that's not the case. There are very few options, in some cases only one option, for the pairing of a particular cation and anion. But for covalent compounds or molecular compounds, we have lots of options. So for example, just looking at nitrogen and oxygen, we can have nitrogen monoxide, nitrogen dioxide, dinitrogen pentoxide, dinitrogen monoxide, dinitrogen trioxide, and dinitrogen tetroxide. Lots of options, and we see some similarities and differences in the naming of these, and that's what we're going to focus on now. These are the prefixes we use in naming molecular compounds. After you've done some practice with naming and going back and forth between names and formulas, you'll probably find that you've learned them without having to sit down and memorize them, but you do need to know these. Let's talk about a couple of rules that we use when we're naming molecular compounds. The first thing is we name the first element in the formula first, and the second element gets an IDE ending. So if we have carbon and oxygen, CO, we have carbon monoxide. We kept the name of the first element the same, and we'll talk about why it doesn't have a prefix here in just a minute. And then we have mono, the prefix for one, with oxygen, which became oxide, so carbon monoxide. Those prefixes are used to indicate the number of each element. So for N2O4, we have dinitrogen tetroxide, 2 nitrogens and 4 oxygens. A few rules on how we deal with some exceptions to using the prefixes in the naming of molecular compounds. If we only have one of the first element, we omit the prefix mono. This is only when it's for the first element and only for mono. So this is why we say carbon monoxide and not monocarbon monoxide. With oxides, we drop the A in prefixes that have an A at the end of it. So instead of saying dinitrogen tetraoxide with the double vowel, we say dinitrogen tetroxide. We try to avoid that double vowel because it's a little bit of a tongue twister. Let's look at some examples. We have SO3, so sulfur and oxygen. We only have one sulfur, so we're going to omit the prefix for that. And then we have 3 oxygens. So we use the prefix tri, and we change the ending of oxygen to IDE, sulfur trioxide. With the prefixes, it also makes it very easy to go from the name to the formula. So we have carbon tetrachloride. So 1 carbon, so we put C. Chloride came from chlorine, so we use Cl, and the tetra tells us that we have 4 of those. So CCl4 is carbon tetrachloride. H2O, which you probably recognize as water, can also be named by the official rules. We have 2 hydrogens, so we have dihydrogen, and 1 oxygen. Because the second element is 1, we still have to include the mono prefix. We only can omit it when it's the first element. We have monoxide. We change the ending of oxygen to IDE. Next, we have P4S10. So we have 4 phosphorus atoms, so tetraphosphorus, and then 10 sulfur atoms, so decasulfide, changing the end of sulfur to IDE. What is the name of N2H4? We have 2 nitrogens and 4 hydrogens, so we need to have dinitrogen and tetrahydride. So B is the correct answer. Let's look at the other options to see what makes them incorrect. For the first one, we see that we don't have any prefixes used. In this case, both elements have subscripts, so we have to have a prefix for both elements. For C, we use bi instead of di. Di is the prefix for 2. And in D, we've omitted the di, which we can only do on the first element if it is 1 of that atom. What is the name for SF6? C is our answer because we have one sulfur, so we can omit mono, and hexa is the prefix for 6, so we have hexafluoride. For A, we don't need a prefix because we only have one of the first element. B, hepta equals 7, so that's incorrect, as well as having the mono prefix on the first element. And then on D, we also see we're using hepta, which means 7. What is the formula for disulfur dichloride? 2 is the meaning of di. Sulfur tells us we have the element S. We have di again for 2, and then we have chloride for Cl. So we have S2Cl2. Even though we have a 2 by both of these, we always leave molecular compounds as they are given. We will see something different when we look at ionic compounds, but for molecular compounds, we have to leave the numbers in the formula.